All right, welcome everyone. Thanks for coming. This is the Scala 3 session where we're going to dive into a lot of code. I'm James Ward. I'm a developer advocate at Google.
I'm Josh Suereth. I am a staff engineer at Google. I'm also a member of the Scala Language Committee. So we've been going over a bunch of these different things and voting on what's included in Scala 3. So we're trying to give you the most accurate shape of what it is today.
And I heard that there's going to be a Bitcoin miner in the compiler this time. Is that true?
It turns out the Scala 3 is a lot faster, and everyone expects it to be slow. So we're actually going to put a Bitcoin miner in to make sure it meets expectations.
Makes sense. Sense. Okay, to get a sense for who all is in here, how many people here are Scala developers currently? Okay, pretty much everyone. That's good.
No, that's about half, actually.
Was that half?
Yeah,
it's hard to see with these
How many
bright
people
lights.
tried Scala at all? Are familiar with the language? Okay, beautiful.
And the rest want to be Scala developers.
How many people want to be a Scala developer?
I want to be a Scala developer.
Okay.
Yeah.
Good.
Our Sandman wants to be a Scala developer, so that's awesome.
Awesome.
Okay. All right, well, let's dive in. So we're going to just start writing some code. So I'm going to use VS Code, and we're going to write some Scala 3. So let's create an application. I'm going to do @main def, and just give this thing a name, and take a parameter, which is a string, and let's return a string that says hello, and then our name.
Do you want to print that to the console?
Yes. We should probably print that to the console, because where's it going to go if I don't?
Otherwise it just gets ignored. Yeah.
It just disappears into the ether. Okay, now we're running SBT, and we're going to compile this thing and run it, and we see hello James. You'll see that my parameter for when I ran it somewhere up here. Well, let's just exit out of that so we can actually see it. There we go. Tilde run, and then my parameter, James.
For those not familiar with SBT, run runs a main method, and it will pass in whatever arguments you have as if they were command line arguments. So we're basically running the command line version, passing James.
That's it.
Yeah.
So that's our Scala 3 application, and that's it. That's all that's new, right?
Yeah. Well, no. So let's talk about some important pieces here. One is, you notice you don't need a class. Like, we just made a method and it exists, and you can call it, and that's pretty awesome.
That's pretty awesome. And then there's that new annotation.
@main.
What's that? @main.
Yeah. So if you want to define a main method, you don't need to do the same kind of pomp and ceremony you had before. For those who are familiar with Scala 2, there used to be this app thing where you'd extend a class that said app. You don't need to do that anymore. You do an @main, and it will synthesize all of the main code that you need to have a main method. And it has a very simple command line parser where all of your arguments will get parsed in the order that they exist. There's an extension mechanism way that you can parse different types of arguments. So if you want things that aren't strings, you can make that happen built in. But it's just a nice little bit of syntactic sugar to get started quickly.
And then also we can specify any method name here, right? Can be anything. Didn't have to, because it had to be. Did it have to be main before? In Java,
yeah.
But
in Java it would have to be main. Yeah.
But in Scala, did we have a?
Depending on what you extended.
Yeah, that's right. Okay, so that's where we're going to start, but we're going to go much further. But before we go into more code, let's talk about what the goals of Scala 3 were. And I don't know, I'm just here to ask dumb questions and write code.
Yeah.
So tell us what the goals are.
Right, so the goals in Scala 3 right now, the first goal was to strengthen its foundations. So Scala had a lot of interesting things it was doing around types, around implicits, but it turns out that some of those things were a little bit exploratory, and we'd like to kind of come back to core and fix them and unify them and kind of simplify what that is. The second So two things that have happened in the past 3 years. The type calculus for the Scala type system has come out. We're not going to walk through that at all. It's just interesting that now it's provably sound in various ways, and where there is unsoundness, we know about it and we can deal with it and account for it. But the core is sound. There's also another calculus called SI that deals with implicits and how to deal with implicits, how to encode them. Both of these things had led to a much better implementation in the compiler and much faster compilation times, because computing types, doing types, it's a lot easier. It's a lot more uniform.
So on the dot calculus, some may have heard the word dotty was like the code name or the previous name of Scala 3, and that name comes from dot calculus. So dot calculus dot t. Yeah, tricky.
Yeah, and
Martin, he I'm sure spends a lot of time thinking about naming.
Yeah, you have to have clever names. That's the most important point of any project you do ever. But DOT stands for dependent object types. Anyway, let's get into the next thing. Make Scala easier to use. So Scala had a lot of rough edges, a lot of dragons, if you will. And one of the keys in Scala 3 is to try to take those rough edges and remove them or reshape them in a way that's more convenient, more expressible, like the way you would expect. Coming from other languages, and have a more gentler learning curve so that when you first step into the language, you're not thrown into all the complexities of Scala just to do like a collection thing. That's kind of a big deal.
I've found some dragons in my days. Yeah. There's a few in there.
Yeah, there's a movie about it. Anyway.
like for real?
No.
Okay.
No, but we should make one. All right. Improving consistency and expressiveness. This is another thing in Scala. Scala, one of the interesting things about Scala was there was no one right way to do things, right? It was more about there are many ways to express solving a problem, and we're going to allow you to choose the best for any given scenario and kind of put them in the same language together. But what this led to sometimes was a lack of consistency across features. So now we've dropped features, we've altered features, we've tried to make things more consistent between the language and kind of improve the constructs that are available to you to be closer to the thing you would write to begin with.
That sounds great. I like the goals. Yeah, we'll see. Oh, a quick note.
Another quick note. Scala 3 is still going through the language process. So some of the things we're presenting to you are proposals that are implemented in the language. The language for Scala 3 is freezing relatively soon. I believe there's another 2 months that you can get changes into the possible Scala 3. And at this point, we're going through all of the changes and kind of deciding what makes final and what doesn't. So some of the things we're going to talk about here may not actually be in the final Scala 3, but most of them are. And we will clarify how far in the process things are when we feel the need, or if you ask.
That's right.
So there are a lot of things that have already been kind of approved as core, and there's a few other things that are still in debate, so there's some nuances that might change, and a lot of really subtle, tricky details that aren't really salient for most people.
Yeah. Okay, let's write some more code. So let's go over here, and let's write a method, right? We'll call this one add2. And it's going to take an int and return an int. And then let's set a val. Let's call it x equals 2. And then let's return I plus x.
So James, where's the semicolons?
Is that valid Scala 3 code?
Where are the semicolons and the braces?
Oh, God. We don't need those anymore.
Oh, man.
Isn't that beautiful? Just like, boom, like no braces needed.
Yeah. Well, Can you do something for me, though?
Yeah.
Take one space off of the I plus x line. I want to see what happens.
One space.
Just one. Yeah.
Well, I don't think my computer lets me.
Oh, your editor is being too helpful.
Oh, no, there it goes.
Yeah,
there it goes. Okay, I am getting some errors here.
So, what happened?
It's confused
Can you show me the error?
Yeah, let's go look at the error. Let's see. Where's my error? There it is. Let's recompile this thing.
Oh, man.
Well,
it worked.
I think I got to call that method, right?
Yeah, because we're not calling it.
Yeah. Let's call this thing.
You got optimized away.
Let's call this thing.
Okay.
All right, here we go. Add2, and let's give it a number. Let's assign it so it doesn't get potentially optimized further away. Okay. Now, let's see. Ooh, what was that?
Oh, man. It found unit. So what happened here, if you go back.
Now, let's go back.
Right? It moved that to a different command line block. Right, so it's not actually part of the method. So you're now failing. But until you called it, it wasn't actually compiled.
That's right. It was just expressions in space.
Yeah.
Yeah. So that worked.
Yeah.
That's awesome. Amazing.
Yeah. It is a lot like Python, yes, or Haskell, or a various number of languages. So white space is significant. Now, another thing you can do, you can put those curly braces back in if you'd like.
You know what? I kind of miss my curly braces. Let's put those back.
And that still works.
Ooh, that looks good. I miss those curly braces.
You miss them? Oh,
I miss them. No, I don't. I think it looks really nice without
I don't.
them. Yeah, I think that looks good.
All right. So
what do you guys think? You guys like the new syntax?
Yeah, let's do a poll. How many people like not having curly braces in their code? How many people want the curly braces in their code? All right. So if you can, tweet why you want curly braces in your code, because I'm really curious. And for those who don't want it, tweet why you don't want it. This is one of those features that is still under hot contention. So whether or not curly braces are involved, there's a lot of discussion going on around it, but that's one of the big things coming in terms of the changes in syntax.
And say that we're using Scala 3, which is currently version 0.20.0-RC1. And so you can go try this. You need an SPT plugin to do that. But then you can experiment with the language and see how you like it.
Try it out. There's a question here. So the question is it white space sensitive if you add braces? The answer to that is it's contextual. So as soon as you open a brace, for that entire block, it's not white space sensitive, but you can have a white space sensitive thing in the middle. And that is only a temporary thing to experiment with white space versus braces so we can make a decision of which one we like better. So the full answer is I don't think that will be the case when Scala 3 comes out. It is today. Okay.
Okay. What else did we
more
want
on
to
this,
highlight
right?
there? Yeah.
So where else did we have braces in Scala?
Anonymous functions was one.
Anonymous functions. What about like for loops and if statements?
Yes.
Maybe we should add an if statement to see what it looks like.
Yep, we should add an if statement. Okay, let's see. If I...
Oh, wait. You put parentheses.
We don't even need those anymore.
Yeah.
Right?
Those.
Let's just get rid of those.
I mean, anything that is curvy like that, let's see if we can get rid of it.
Just all the curves. Just get rid of all the curves. Okay, if I is equal to 4, then let's do 2 for some reason.
Oh, put a then.
Then?
No, I mean if I equals 4, then.
Oh, then? Like that?
Yeah.
Yep.
And then you can have an else.
And then an else.
Yeah.
Yeah. Awesome.
All right.
I don't know why you would ever want that logic in a program, but there it is.
Point being, and then you can also make this be a one-liner if you want. But there is a then in if statements now, and all of the control structures within Scala now have parenthesis and braceless versions. So that is actually the notion of then is something that is independently being evaluated over the white space syntax. So an important bit here, if we walk into the if-then, let's do a for loop, because I think this was one of the biggest ugly pieces of Scala syntax people run into quickly. Let's do
code. I don't know how to get back to where my code was.
Oh, press escape a bunch.
There we go.
Oh, okay.
There we go.
There you
We're
go.
back.
You're back. All right. So for some reason, all right, we're gonna do a for loop here. Okay. So to add 2, we're for no good reason, we're gonna say.
Oh, not those float
array ops. Yeah, auto completion is hurting me here. Here we go. For I 1 to 10, right? We want to add 2 more than once. So we're going to just add 2 a whole bunch for no reason whatsoever. So for I and j, then we want to do, we'll do I plus 2. Oh, wait, I did I. We have to do x and y here. Sorry.
Oh, yeah, we got an I parameter.
We're just going to print this a whole bunch because we're really proud of it.
It is nice.
And then we still need to return an integer, which is what it's telling me. That's a for do. That means I'm doing something, right? It's a for loop. So I need to return something. So now I'm going to return that I plus 2 again. Just for fun.
That's like the side effecting version of a for comprehension.
Of a for comprehension, yeah. But if those of you who might remember Scala 2, when you had one of these and you had those braces and you had a multi-line for where you were iterating over several different things, right? You had this really ugly syntax where you'd have an end of a curly brace and then the opening of a curly brace for your block that would run in the for loop. So that's fixed with this new do syntax.
Yeah, that was kind of nasty.
Yeah. Anyway, minor things.
Nice.
Cool.
Okay. All right. Let's see if we can get my editor to get back to where it was. Go away. I don't know how to use this thing. That's okay.
Okay.
We'll continue.
Cool.
Okay, we showed that one.
That was for do.
Yep. Okay.
So another big feature in Scala, I think probably the killer for me, where like I want all languages to have this, is pattern matching, which is not just a switch statement. It is a switch statement on crack, where I can switch over anything. I can make custom patterns. I can, figure out all sorts of crazy things. I can have if statements in my cases, all sorts of goodness. In the new world, if you don't need braces with pattern matching as before, but otherwise everything is still exactly the same. The beautiful thing here, though, a subtle nuance for those of you who write custom pattern matchers, is it's no longer option-based. It no longer requires the Scala standard library to work. So if you're trying to do something nice and embedded, you can actually create your own custom patterns that can be more optimal with a smaller library footprint, which I think is important.
Yeah, I like it.
Cool.
Okay, what's next?
Let's make a class and construct it.
I don't think we need to type this one.
Yeah.
It's pretty basic. Okay, does anybody notice what's different with this one? Okay, there's no new, because there's no apply function for this, because it's just a class, not a case class, right? But there's no new there. So what Scala 3 is doing is it's first going to see, do you have an apply function that matches the parameters? And if not, then it's going to try the constructors.
Yeah, so in Scala, traditionally you had this notion of a companion object that had factory methods called apply, and you could use those to construct classes. And case classes would give that to you by default. But then you had this weirdness between like regular classes and case classes. So now the way it works is you can define factory methods in a companion object if you would like, but you don't have to. You can actually just instantiate things without new, because the compiler can figure that out for you, so why do you need to type it? And now you have a uniformity between those two. And if I move from having a constructor to a factory, I can actually make that in a way where I have to recompile my downstream code, but I don't have to rewrite it.
Awesome. Okay, what about traits? There's some new cool stuff in traits.
Yeah, there is. So let's make a trait for animals and have them be able to like talk to us.
Yeah.
Right? But there's some data that I want to pass into the trait.
This happens.
Yeah, but now I can. I can actually pass in a argument parameter to a trait, and then when I extend it, I can have the extension pass that in from my constructor. So traits actually now have constructors, whereas previously they did not. And this solves a lot of issues with traits in Scala around initialization order and around initialization laziness. For those of you who may have heavily used traits in the past that always defined everything as either a def or a lazy val, those days are gone, at least mostly. Yeah. There are still times you need to do that, but that's you have the option now.
So you still can't instantiate an animal in this case, right?
You have to make a new class and instantiate that new class.
Yeah, so that hasn't changed, but you can at least give it parameters.
Yeah.
That's nice.
A few rules about that. When you instantiate a trait, if it lives in a class hierarchy, there is one instance where you will pass its parameters. There cannot be two. That's the only caveat with traits. But you can still do the same kind of multiple mix-in of traits that you always had in Scala.
Awesome. Okay, let's write some other code. So we're going to go back here, and let's go take our method, add2, and let's just, for some silly reason, add another parameter onto this thing, right? And let's go back to I plus 2, just for some simplicity. Let's, instead of an int, let's return a string. And then let's also take that thing and add it to our string, right? So let's return now $s, $y, and then the $s that we passed in there, okay? Okay, so now here's the cool new thing. Let's go create a function, a new function from that add2, and we can just pass it in like that. And now we are taking that thing that was defined as a def, a method, and now we have a function. So if we were to print out that f so we can see what it actually looks like, and rerun that, then we should see our lambda right there. So got our lambda. We can also put in a parameter. Let's put in 2, and that's going to give us an f that now takes a string parameter. So let's give it that one. And so if you're familiar with Scala 2, I think many of you are, then this is just making it so we don't have to do that little underscore syntax that we had to do before.
Yeah, one of the really, really big consistency wins in Scala 3 is around functions and methods. The thing that's really, really, really cool in Scala 3 is you no longer have the same kind of issue with methods not being able to be created as functions. Almost every, and I think every, but I don't want to say every because I'm not sure if there's weird corner cases still, but we've tried to have it so every possible method you can write can be expressible as a function. And so that includes things with type parameters. Should we do a type parameter example?
Yeah, let's do a type parameter example.
All right. So for those of you who work with like lists of things, we're going to create a head method which takes the front of a list. So let's take in a what do we want?
Just a list of t. I would say.
Just a list of t. Okay.
Yeah.
All right, and we're going to return the first element of that list. Now this could fail.
We'll just return a t.
But we'll just return what x dot
paren, yeah.
Paren 0. We'll return the first element, right, for head. So head now is a method which has a type parameter, right, that works against lists.
Yep.
Cool. And it should work against any possible list. So if we change f to be this new method, right, then I should be able to pass any kind of list in here and it should work. So if I take f of a list of 1, that should work and compile. And if I, no, that's not working. Sorry. I'm still getting used to the keyboard.
I know, me too.
All right. And if I take a list of string, right, notice that f, it's the same f, right? But it's agnostic of type here. It actually, the lambda understands that it can be against any possible type.
So that wasn't possible in Scala 2, right? It wasn't possible to have those functions, the val functions, be parameterized like that.
Yeah, there was a way to express it. And when you looked at that code, basically you probably never wrote Scala again afterwards.
Yep.
So
it was not fun.
Unless you were me and you were like, this is amazing. Anyway.
Awesome. Anything else on those functions? I don't think so.
Yeah.
We're good. Okay, union types. I'm going to do this one. I like this one. Okay, so let's say that we have this add2 function, and we want to be able to essentially like overload it. So we want to be able to take either an int or a string, right? Either one of those. Well, what we can do is now we can pattern match on that thing, and we can say, all right, if we let's make this let's make it something else, z. So then I got a match on z. And now we're going to say, all right, if we have an integer, then we're going to return I plus 2. And if we have a string, then we're going to take the string and we're going to toInt it, which is not safe, but hey, we're going to do it anyways, right? And so now
you probably want to return an integer then.
Oh, yep, thank you. Let's return an integer there. And so then what we can do is let's call our add2. And let's first send it an integer, and then we can also add 2 and call it with a string, right? Either one. So let's see if that thing works.
I'm trying to make it explode. I like it.
What did I do wrong?
No, it's exactly right.
It is.
You got to pass it.
I didn't do anything wrong.
String.
I have to see what?
Yeah,
ASDF can't compile.
Yeah.
Okay, let's try this again with an actual something that can be converted to an int. All right, there we go.
Yeah.
So, okay, these are called sum types. These are algebraic data types, and this is the sum type, the ability to combine these two types together into a new type.
So what if you pattern match on something that's not in that type? What happens? Like, look for a Boolean in the pattern match.
Let's see. Let's see case B, and that's a Boolean, and let's return 2. Okay, let's see what the Scala compiler is going to tell us.
Oh, man.
Oh man, it should have like given us a warning or something, right?
Yeah. Actually, I think it does. I think when you're in run main, it's not. Anyway, sorry.
All right, we're not seeing our warnings.
I guarantee you. It gives
we
you a
turned
warning
off strict mode. Maybe it's because we turned off strict mode.
Oh yeah, sorry. Okay.
Let's go.
Note to self: run in strict mode.
Yeah. Let's turn that back on.
Okay.
Because I like being strict. All right. Let's reload that thing. And then let's see if we get our warning. You're saying we will. You want to bet on it?
Yeah.
Yeah. Okay. Let's see.
Oh man,
you
I
lose.
fail.
You owe me a beer.
Okay. I'll pay you later.
All right.
Wow. Okay. Anyway, so it does. There are pattern matching warnings.
I'm not sure. Live.
I'm not sure why we're not seeing it here, but I have seen it myself. Okay.
Did you know that Boolean extends int?
Boolean extends int. Oh, no, well, why don't we try here to pass in a Boolean? Because then that will definitely fail.
That would definitely fail.
Yeah.
Right.
It should work on both sides of that, though.
It should.
Yeah.
It should.
Okay.
See, look,
it's failing to compile.
Like, hey, you can't do that. You can't do that.
Right, because it knows that you need an int or a string.
Yeah. That's cool. I really like the ADTs. I think they're awesome.
Yeah.
Yeah.
Yeah. This turns out to be surprisingly convenient in some manners. One thing that we'll get into a little bit later. Actually, I have the slides out of order because we're walking into Enums next. Yeah, we'll get into that later. Let's walk into Enums because you just mentioned ADTs.
Yeah. Let's do it. Let's do Enums.
Yeah.
Are we doing Enums?
Well, this was how we motivated Enums. Yeah.
Oh, yeah, that's right.
Yeah.
Okay. No, so we're not doing Enums yet.
Well, yeah, sorry. I'm getting ahead of the talk.
You are.
I'm so fast.
Okay. First, we're going to do extension methods. Okay. So we're going to define an extension method. This is a new feature in Scala 3, if approved, right? We first need to tell it what thing we're going to put this extension method on. So I'm going to say it's a string. And then I'm going to give it a name. We'll call it green. And we'll tell it it's going to return a string. And now we've got a method where we can do something on all strings that call green. So let's return $s, $green, and then our $s, and then our $reset.
For those of you who don't know, Scala defines a console object which has ANSI terminal coloring things available for you to make use of, which we are importing at the top. So capital green is the ANSI terminal code to change your text to be green. Reset is the ANSI terminal code to reset your text's color to be the default.
Is that going to work? Right?
Yeah.
Boom.
Oh, man.
And it's green. Amazing.
Wow. So now we can dot green everything.
Now we can dot green everything.
So one of the issues in Scala previously, if you wanted to do extension methods, you could encode them, but it was a lot of code and a lot of understanding of the language that's well beyond what you really were trying to do. You're just trying to add a helper method to something. So now it's more directly exposed, right? It looks a little bit different, for those of you used to Scala 2, but effectively you define a method where the first argument is the thing you're extending, and then a normal method signature after that.
Love it. Awesome. Okay, now we're going to do enums. Enums.
I say enum because of enumeration.
Yeah.
But you can shorten it however you want.
All right. Enu.
For those of you who use Scala 2, how would you have done this before?
Sealed traits.
Implicits.
Which one? The extension methods? Is that what you're asking about?
Oh, no, I'm asking about enums, enumerations. Java enums, yeah. There you go.
All right. Well, now we're going to do Scala 3 enums, where we just say enum, color, and then let's say red, green, and not green, and blue. Okay. That's our enum. Pretty awesome, right? Anything else we need to say on that?
So a few things here. This will compile to the same thing as a Java enum if it can. You can force it to compile to a Java enum if you declare enum color to extend javalang.enum. But you can do a lot more with it, which we'll walk into in a little bit.
Well, let's do it. Let's do a val on here on our enum called ANSI, and that's going to be a string. Right? Mm-hmm. And now we need to add the ANSI.
You need to extend.
Thank you.
Yeah, it looks like a
that's
case
right.
object definition.
Yeah, that's right.
Yeah.
Extends our color with the red in it, right? And then let's do a case green, which extends our color with blue in it. No, not blue, green, right? And then our blue, which extends our color of blue. Okay, now we've got those. Cool. Now let's use them. So we're going to change our extension method here. We're going to call it color. We're going to take a parameter in here, which is going to be a C color, right? And then inside of here, instead of green, we can put in here our C.ANSI, right? And then output our string and our reset. Okay, now let's go give it our color, and we'll do color dot red, right? And let's see if it works. Red.
Nice.
Amazing.
Nice.
Amazing.
So enumerations are a big simplification over like sealed traits and case class hierarchies in the past. It compiles down to about the same thing as they were. And as I said, it'll optimize to a Java enum when it can, if what you made is as simple as a Java enum. So another important thing here is enums also allow what is known as generic abstract data types, where you can have type parameters on them. You can have subcomponents in your enum that define like sub-enums and subclasses and all sorts of craziness. It is a very, very, very robust enum. So the simple example of that is if you want to define an optional data type, like you're familiar with from Java or from Scala, we can define that as simply as this. And that's just the isPresent method. You can imagine what map and all that would look like. You can implement methods on each of the cases, or you can implement the method on the type. So it's incredibly flexible now. And this has been, for me, this has been a really nice way to get rid of a lot of boilerplate in my code and a lot of my class definitions, actually.
Nice.
Cool. Related to optional and the union types that we're showing, there's a proposal out right now. There's an implementation to get rid of null in the core language. And this would require you, if you want a type to be null, to have or null in it. So those of you familiar with optionals in Scala, that's generally how we kind of deal with null and like shove everything in an optional and then deal with it there. This might actually make code a little bit more simple, where if you take in a string, you can't get a null. However, there's a lot of talks because Java compatibility is a thing, and you need to be able to handle types from Java, and we don't want to just or null every single Java signature out there ever, because that would be hard to deal with as well. So there's a bunch of trade-offs going on in discussions, but this is something that might be coming, and it's hotly debated right now, and it's pretty exciting.
So one of the things I wonder about with this, I think I like it, but I think it would make me wonder when I should use an option and when I should use the sum type. So, anyways, food for thought.
Yeah.
What about implicits?
Yeah, this is the elephant in the room. So what was Scala's greatest and worst feature? My opinion, implicits. They allowed so much like nicety, so much really cool things you could do in the language, so much expression, but they also had so many warts and so much of the usage of them required you to understand the compiler itself or rules of the compiler to be able to make use of them well. So one of the big significant things in Scala 3 is contextual abstractions that are meant to solve the issues with implicits. As I mentioned before, there's a calculus around implicits, and Martin put a big manifesto of what needs to happen with implicits to clean them up. The too long didn't read of that is implicits should look different, right? You should be able to tell that this is part of a contextual abstraction. This is not just vanilla code. It needs to look different so that you're aware of it. Second, they should be readable. You should be able to look at the code and figure out what the heck is going on and understand the mechanics behind things. If you can't look at the code and figure out what implicit is getting pulled in or where it's used, that is a major, major, major problem with it, and that will lead to issues later. So let's resolve that. The second thing is, around contextual abstractions, you're abstracting over types, not names. Okay, and that's like, I don't care what the variable name is. I care that I have something that handles integers right now. Like when I'm trying to serialize, I don't care that the serializer is called serialize int, version 1. All I care about is I have a serializer for an integer. Give it to me right now. So those are kind of the 3 principles that lead to everything else.
Yeah. And how many research papers were done behind this?
I don't know. Probably
Many.
a lot. Probably a lot. I only read 2 of them.
Okay.
Okay.
Let's code it and then we can talk through it.
Yeah.
Is that cool?
That sounds good.
Okay.
Sorry, I pressed the button first.
That's cool. Okay. So let's set up an implicit, or the new implicits. What we're going to do is we're going to give this thing a new parameter on our color function, and we're going to say given, and then we're going to take a color. Okay?
We need to get rid of...
Sorry, I could have just replaced that. Yeah. Okay, so you'll see that the body hasn't changed at all. It can still access that color, right? But now we can specify, we can pass the parameter around as a given. So to do that, let's go over here, and we're going to say now given a color, which equals... We'll just set it to color.red. I cannot type. Here we go. Now that's now an implicit. But you'll see there's not a name for that thing. We didn't give it a name. It should still be working just like it was before, right? So I'll recompile and run there. But so this kind of looks a lot like implicits, or feels a lot like implicits. But one of the nice things, as Josh said, is we didn't have to name that thing that was actually filling in the implicit. It was just done by type.
Yeah, so there's a few important things here. One is this parameter list, right? It now abides by the same kind of parameter things, so we can actually have next color here if we wanted, and we could do a next color type that we grab in, and you can have more than one given parameter list. You can put them in any order. You can mix and match. That's now completely uniform. But they do have to be called out as givens. Another thing is we have a given definition here, right? When I define that given definition, it's available in the same scope that the given was. If I want to, I can actually move this. Does alt work for this? Nope. My bad.
We're IntelliJ folks,
I know.
Through and through.
I know.
Yeah.
Okay, so given color equals color.red. I can put it up here, and it's available in that scope. And you notice I'm throwing it kind of like in a globalish scope, but it's in the same source file, so it's fine. If I wanted to make use of this somewhere else, there's a new way of importing things that are given. In Scala, originally the default was if you import from like a method or a package, it would give you all of the members of that as things you can reference by name, and it would give you all of the implicits. Now, givens are explicitly imported. You can wildcard import your givens, that's fine. So if I were to put this inside of a object, context, if I were to put this inside of an object...
We don't need braces.
Oh, right. Why am I doing that?
Braces.
It auto-completed, man. I couldn't stop it. It was too much. Okay, so then we can import context.given, and that will put that given in this scope and allow me to make use of it, right? But I legitimately need to import the given. And if I want to import a specific one, like I don't want all of the stuff it gives me, I'll just import the color, right? That has to be, sorry. This one still needs a curly brace.
Ooh, ouch.
Yeah.
I thought we were going to have no braces today.
I know. I tried.
We were close.
But I can explicitly import the givens for that type as well. But I have to explicitly import the givens separately from importing names. They are now distinct things. And that actually solves a lot of issues with understanding what I'm pulling in and where. And it also means there's a little bit more pomp and ceremony around providing givens and making sure people use them because they have to be explicitly imported.
Awesome. Okay, so you've seen givens. Let's talk about a real world use case for them.
Yeah, what's the most important use case of givens is effectively passing context around. These are contextual abstractions. If you think about a lot of web frameworks in the Java ecosystem early on, and even today, a lot of what you do is there's things you have to pass around as a framework or a library that you provide to users. And the way you would do that would be maybe slip it into a thread local. and then have all these things where whenever I want to change threads, I have to like take this out of the thread locals and put it in the new thread locals and all that kind of copying. Scala, you shouldn't be doing that. You should actually just be providing these things implicitly. The compiler will fill it out for you and make sure everything that you need is available, and that's one of these abstractions. So in this case, we have this notion of there's some thread pool that I can provide work to, and I have a whole set of code that needs that thread pool and will pass it to it. But I don't want to keep passing the thread pool to all these helper methods, so I provide them as a given context in this library, and then the users will have to have a given available when they call me, or they can pass it explicitly. So that's what the second option is. If I don't want to use the implicitly available one, I want to use something different, I can provide a given argument list. Now, it is called out explicitly as a given. So you know that like I'm not using the magical one, I'm actually directly passing my own, and it's called out and it looks different.
Nice. I like it.
Cool. So another advanced thing, this is just some convenient syntax. If you want to provide a given locally in scope with a particular type and you're providing a new instance of that type, you'd literally just say given the type name and then you implement it directly. You'll notice there's curly braces there. That's just a temporary bug.
Oh, ouch. What about the summon?
Ah, yes. Okay.
I think, Kotlin has some cool keywords. I think summon is our first like real cool keyword. Yeah, that's because we really want to be wizards. Yeah, I like it. Yeah. My kids are into Harry Potter, so I apologize if there's too many Harry Potter references later, but I can't help myself. So summon is a thing that allows you to grab a type off of the implicit context, the current instance of it. So in this case, my context requires an execution context, and I'm defining a new given, and I'm actually summoning the existing execution context off of it and providing it here. That's cool.
Yeah. One of the things I might not have called out, but I think is rather important for Scala 3, you notice the lack of types that I'm writing. Effectively, the types that I'm writing are really either about givens, because types are really important to givens, or it's documenting the inputs and outputs of my method, but I'm not writing a lot of types otherwise. Here in my context, I'm not actually putting the types of the defs, because the compiler is able to infer these things. Okay. And then this was about explicitly importing. This is a more advanced usage. When you import givens from another context, you can actually wildcard import them and do specific types. So if I want to import all of the instances of ordering, I can have this little question mark and get all the instances. If I want to define ordering for integers and for lists of anything that has an ordering, that would be how I define it.
And this also allows us to set the order in which the givens get used or applied, where with the implicit syntax, or is that later?
That's later.
Oh,
that's
not
later.
Yet. Okay.
Yeah.
Jumping the gun.
Okay. Another important thing is we mentioned that functions and lambdas and methods are kind of all the same thing, or you can go from one to the other. You can now define lambdas or functions that take givens, right? That take in those implicit arguments. Like that is a thing that you can do, and there's a type signature for it. When you define a function, right, you can define a given. Now, what's interesting about this is Martin's slide that I stole. So I'm just giving him credit now. So it's not actually stealing. It's
too many braces.
Too many braces. Yeah. This was one of the motivating examples, which is kind of interesting. So here, what I want to do is I want to have asserts in my code. But when I generally write asserts, I want to write this last line here of, return this value, right? But what I don't want to do is I don't want to like assign a temporary value, assert on it, and then make use of it immediately to just return, right? What I want to do is have all of that captured in one expression because it's much more concise. So I want to be able to write, ensuring result, and that result expression is a lambda, right? That returns true or false. So I want to be able to write this. So how do I do that? We're going to make use of some other more advanced Scala 3 features. We're going to define a ensuring method, right, that takes a given wrapped result and returns a Boolean. So that is, I'm going to be implicitly providing you a wrapped result, and you're going to be providing me with a Boolean, and I'm going to assert on that. So I'm going to give you the current x that I have. So this is an extension method called ensuring. I'm extending the result of sum. I get that in as x, and then I give that to the condition, assert on it, and then I return x, right? This result method that's right here says, oh, if I have a given wrapped result, I'm going to return its value. And then wrapped result is this new type called opaque type. This is an interesting thing in Scala. I can define a type alias that hides the underlying type, but does not exist at runtime. I'm not creating a new class. I'm not creating a new block of memory. It's completely hidden. It just disappears.
Compiled away.
Compile it away. So effectively what I've done here is ensuring, right, will take in implicitly this whatever value it had and allow me to write this expression, and I can write it in this nice, concise way. This is kind of if you don't understand this example, don't worry. There's a lot of even more advanced examples with this that are interesting and compelling.
Of course there is.
Yeah. Automatically closing resources is one example, being able to track effects, all sorts of cool stuff that they've been doing some research on this notion of these given functions, a lot of simplifications in terms of methods and what you can do, which is pretty cool.
Pretty cool.
Okay. Let's talk more about some contextual abstractions.
Yeah.
One of the things that's really, really pushed heavily in Scala is
type classes.
Type classes. Yeah.
I mean, they're amazing.
How many, well, I guess we don't have time to pull. Type classes, the first time I was introduced to them was in C++ with the standard template library. And when I saw them in Scala, I was like, wow, this is amazing, but so much ceremony. And they've kind of removed a lot of the pomp and ceremony with defining type classes. So I can define a trait, and I can define that I need types that have instances of that trait. So if you notice, this trait takes a type parameter, provides a method. I can define an extension method that requires that whatever type I have has an instance of that available as a given. I can summon that given, and I can call that method. And now I can effectively add these concepts to types, right? So joiner is the notion, if you do like MapReduce, of how to do reduction on types. I can define generic joiners and import them. More importantly, I can start doing derivation of these things. So if I have a very simple type, like a calculation that just has a few counts, okay, I can automatically derive a joiner, where if I know how to sum integers, right, I can derive the calculation because I know that calculation is two integers. Well, I can just sum them together. That could be my default derivation of what joining means for this particular case class. And I don't have to write any code myself. I just write derives. All right? Now, what's really cool about that is it's a thing that anyone can do. You can provide a type class where you can define a default way to derive things for any possible class. You have to implement a derived method on your companion object that takes the type you're deriving for. And when I write this code of saying this derives joiner, it's going to attempt to call that method. All right.
Yeah, this is good.
So under the covers, what you're going to do is you're going to use this new keyword called inline, which is a method which does not run at runtime. It is actually lifted and moved to where it's called and compiled there. And I'm going to inspect my types, I'm going to rip them apart, and I'm going to do things in the compiler. This is not macros. This is a brand new feature. And it's really, really, really powerful. And I don't really think we have time to dive into the full details of it.
We've got 2 minutes.
So we're going to go into some of it. So this is metaprogramming. This is Scala, the things everyone was using macros for that led to really slow compilation times, but like built-in default and not slow. Okay, so inline methods. These run in the compiler. What's important about this is there's also inline conditionals where I can run if-else statements in the compiler. There's inline matches where I can actually do this match in the compiler, so only the particular type that I need is inserted where it matters. There are erased terms. So this is, I want to match on something, right? And I don't have a value for it. I just want to match on the type. Okay, here I'm matching on something where I have a value. I have an X of type T, and I want to match on the type and do something different based on the type. Here I don't even have a value. So this is an example where I'm computing, let's say I'm running a serializer, how to calculate the size in bytes that I will need to allocate a buffer to write to, and I'm doing it at compile time without an instance of a byte. I'm just kind of calculating how big, integers, longs, doubles are independently.
And you can set compilation errors in this syntax as well that make it nice and pretty.
Yeah, that compile time.error will give me an error at compile time. It'll be that error message. I can actually give my users a decent compile time error message. And again, all without macros. The other thing that's interesting here is I can look for givens in scope. So in this inline method where it's called, I can say, hey, do you have a joiner available of type T? If so, give it to me and I'll compile. Otherwise, it will fail to compile and give you an error message that it couldn't find a joiner.
That's awesome. So this replaces a lot of the macro stuff that has made things in Scala slow or complicated, some of the more magical stuff.
Right. And so the last little bit we'll just skip here is if we look at typeclass derivation, we can actually tease apart tuples. Okay, this is where we take head and tail tuples and we try to write a particular element, then write the rest of the elements, and we can write a derived method that automatically rips apart the types of a case class for us using built-in stuff. There's a library to make this simpler already, but the raw mechanics are there for if you want to do more advanced things, which is pretty awesome.
It's pretty awesome.
So yeah, TLDR, advanced archinery without macros.
Woo! Exciting.
And macros still exist.
They still are there. Yep. You can use them if you need to.
Okay.
Okay, we are out of time. We'll be around if anybody has any questions, but hopefully that was useful for you, and hopefully you use Scala 3. So thank you.
Thanks, everyone.